Hi everybody, I want to teach you today the graphical method for solving the structure member forces in the members of the structure using Bow's notation. Here we have a structure member with two forces acting downwards, 120 kilonewton and 140 kilonewton. One force acting at this point, at this pin, to the left horizontally, and we got two reaction forces here, one VL vertical left and one VR vertical right. This is a roller support and this is a fixed support. So for fixed support we would have two reactions, one would be horizontal and one would be vertical. So let's first draw the vertical reaction force from this point, and we need to calculate that. That's quite simple, and that would be, as you can see, there is only one horizontal reaction to the left, so there would be one horizontal reaction to the right. Some of the forces in the horizontal reaction should be zero, therefore AT should equals to HR. So we got that as AT. So let me put the direction as well, so it would be more clear, and I have written that here. So now we have to find out the VL and VR, how much they would be. So first we have to understand that sum of the vertical forces is 0. That means 20 plus 40 should equals to VL plus VR, as you can see here. And then taking a momentum from, I don't know, at this corner here, so that we would eliminate this unknown force here, unknown reaction VL. So we start from 14 kilonewton, which is acting downwards, which would have a moment in the clockwise direction. So clockwise direction moment 40 would be 40 multiplied by 8, and there would be an anti-clockwise direction 80 kilonewton, and that would be 80 multiplied by 3, which would be opposite hand side of the equation, because one is clockwise and other is anti-clockwise. So we should always keep that in our mind, that we equate clockwise moments with the anti-clockwise moments, so that the equation would be equal. So we got this as well. Now we get VR is also anti-clock, so it stands in the other side of the equation. So VR multiplied by this distance 8. Therefore if you solve this equation, you get VR is equals to 10, and putting VR is equals to 10 in our vertical forces equation, we will get VL, and that would be 50 kilonewton. So far it was a hand calculation, but now we're gonna move on to the graphical method of solving the forces in these members. It's a very interesting way of solving. Don't need to do any hand calculation, it's just drawing lines and understanding their meaning, and each line will represent a force. So we're gonna first divide this structure into different regions. So we're gonna start from this region number A. So we start from alphabetically and giving names to these regions. This region would be A, and we go and clockwise direction. So this would be B, this would be C. I mean, there's this line between B and C, and there is a line between C and D, and there would be a line between D and E. There would be a line between E and F, and it would be a line between F and S. So we came back, we made our circle in the clockwise direction. Now we make names for these regions, closed regions. These were alphabets were for open regions, and letters numbers we will use for the closed regions. Let's start from left to right. This one is 1, then 2, then 3, and the last one 4. Now we made our basis for constructing our force diagram for calculating the forces. So first we have to find out, we will slowly start to draw our lines. So we know that there is a vertical line between, and that would be our force VL, between A and B, which VL, which is 50 kilonewton. And let's say 1 kilonewton is same as 1 millimeter. Therefore, if we draw a 50 millimeter upward, that would represent our 50 kilonewtons. So let's draw that vertical line upwards, and it would be 50 millimeters. So 50 millimeters is our vertical lines upward, and the point that we move from is point A. We move to point B. Now as we are in point B, we face another vertical line, which is this time downwards to go to C, and that is 20 kilonewtons. So 20 millimeter we need to move downwards. We draw a line 20 millimeters downwards. And sorry, this line, okay, we have to dimension that line. So we put this as 20. Delete this and make this 20. Alright, now we are back on the track. So we got 50, we got 20, and that point would be point C. So we reached here. Now to go from C to D, we need to go 40 newton downwards. And we go 40 newton downwards, we draw a 40 millimeters line downward. So line 40 downward, and this is our 40 line downwards, and we reach to the point D. So D would be here. So let's put a bit more up so it would be more clear. And now we have to go from point D to point E with 80 kilonewton to the left. So we draw a 80 millimeter to the left. Very simple. And now we point that as point E. Now we have to go back from E to F with HR, sorry, standing here. So HR is, where is HR? HR here. HR is 80 kilonewton. So E to F we go back, and it's towards the right side, so we get the point D and F as the same point here. So it's almost half of our procedure is done. Now we have to move between these regions from point 1, 2, and 3, and 4. So first we draw a point and find the point 1 in here in our force diagram. Let me write the force diagram here so that you would know what I'm talking about. Force diagram, if you don't understand my accent. So now we want to find point A. We know that point A is connected by two regions. One is B and between B and C it is. So, and it is vertically connected to B and horizontally connected to C. So it should be at point C. So this point C is our point 1. If it is not clear now, if we wait for some time, it will be more clear as I explained the other steps. Now we have to find point 2. Point 2 is connected between region 3 and A. So it is a, or we have to go use our reference that we mentioned before, that is point 1. So it is diagonally between 1 and A, and it is horizontally with A. So if you draw a horizontal line from A, okay, we leave it here, delete this, you know, and we have to draw a diagonal line from point 1, which is here, to this horizontal line to represent point 2. But here the angle is very important, to know the exact angle between these two. So we know that this point is point 2, but to find the exact place here we need to find this angle. So this angle should be same as this angle between 1 and A, and that would be tan inverse of 3 millimeters by 4 millimeters, 4 meters, 3 meters by 4 meters, which is 36.87 degrees. Okay, so tan inverse of 3 by 4, we get this angle. So this point is now 2. Now we need to go and find point 3. Point 3 is between a vertical line separated by 2 and a horizontal line separated by C. So we draw a horizontal line from C and a vertical line, as you can see, from 2, and this point would be our point 3. Let's cut this extra part. So far we reached to point 3 and only one point left. This is point 4. Point 4 is diagonally connected to point 3, and it is horizontally connected to E, vertically connected to E. So if we draw a vertical line from E, let's put it here, and a diagonal line from 3, these 3, it should be the same. It should be point 4 here. And let me cut this extra part. But again, this angle is important, and as we know, this angle between this line and this line and this line and this line are the same. As we found before, this line was 36.87, this should be also 36.87. So I dimension it for our 36.87. So we got that. Now our force diagram is complete. We got the connection between all our points. Now all our concentration should be here, and D and F are same. Okay, now if we measure each of these lines, that would give us the force in that member. So for instance, this is 50 millimeters. 50 millimeters means 50 kilonewton. So the line between 3 and 4 is 50 millimeters. That means 50 kilonewton. 3 and 4. There is only one line between 3 and 4, and this is this line. This is this member of our structure, and that would be 50 kilonewton. Okay, and now let's look at, for example, F, between E and F. So there is this, which is 80, so this will be new, and now between 2 and 3 is 30. So 30 millimeters between 2 and 3. So here this member should have 30 kilonewton force in it. Okay, so like this we can find almost all the forces between 1 and B. Let's say 1 and B. So this is the line between 1 and B. Okay, so we go back to our force diagram. We check the distance between 1 and B. Just check the norm. I think this measuring is not right. Now it is 20 millimeters. So the millimeters means 20 kilonewtons. 1 and B. So it has 20 kilonewtons. Now we have to find the directions of these forces to understand whether they are compressive or tensile forces. For doing that, we will consider first this corner. As you can see, this corner, there is a vertically 40 kilonewton coming downwards. Okay, and that is on this point, which is in here, from point this line E, 4, between 4 and E, 4 and E, 4 and E here, and we have to go, the force have to go vertically upwards from here. As this comes downward between C and D, I'm sorry, it's between C and D, 40 downward, C and D. So there will be a vertically downward between C and D, and then we have to go a loop to come back to C. Okay, and so we go to D, from C to D. So we are here now. To go back to C, we have to find the shortest distance, and we go here, then we go here, and then we go like this. We got back to our point, original point C, and between C and D, this line, sorry, is line C between A and D. I'm sorry, A and D, between A and B, A and B. So it comes downward and goes a rotation like this. Now we consider, I'm sorry, it was between C and D. So it was C and D, this line C and D, this line comes and goes like this. Now we consider this point, which is between A and B. There is a vertically upwards, A and B. This is A and this is B. So we have to draw a line this vertically upward. So we have to draw vertically upwards, and then it comes back down, because otherwise it will go to the air, and then it comes in this direction, and then it comes like this, and then it comes back to the same original point. Now using these points we can find the stresses. As you can see, there is a line between A and 4. A and 4, which is vertically downwards. A and 4. So we know that this is this vertically downwards one, so it should be opposite to this. Opposite to this, there is a force, and there is a force coming upwards, so there should be a force opposite to this, and there is a force going to the right, so there should be a force opposing that to the left. And then we checked that there is a VL force going up, and there should be a force coming down here at this point. And because there is a force going up down here, there should be a force going opposite to that direction. And then we have to check back our we can do one more here easily. This is this side, so it should come in this direction. And now we check between 1 and C to find this line. 1 and C. 1, this is point 1, and C. They are at the same point. That means there is no force here. Sum of the forces at the same point is 0. So there is no force in this member. Now we have to find the force between 2 and A. 2 is this point, and A, which is to the right. So we have to draw the arrow towards right, and then this is left, so this should be cancelled with this, and this should be cancelled with this, and there would be a force coming like this to repel these forces here, to make it like this. There is no force here, and this is cancelling that, so there is another compression force here, and this force would go in this direction, and this force should be cancelled also with this, and there will be a force like this. So here the force would come like this, and this force would try to go up like this, and this force would try to come down. So we got all our force directions as so these forces which are arrowing towards each other, they are tensile stress, and the one who are opposing each other, they are compressive force. So this compressive, 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 tensile, tensile, tensile. And that's it. This is all of it. I hope you enjoyed it, and I hope that you will continue watching my programs and learn more and more about mechanical engineering and the methods of solving problems. Thank you very much for watching.